of n nodes labeled from 1 to n. You're also given the times, a list of travel times as a directed business. Okay, you're given a graph actually. Okay, here's the source node and here's the target node, and this is the time it takes for a signal to travel from source to target. Okay, so it is the directed edge with weighted graph. So we will send a signal from a given node k, return the minimum time it takes for all the n nodes to receive that signal. If it is impossible for all the n nodes to receive the signal, return -1. All the n nodes to receive the signal, return -1. Otherwise, return what do we need to return? The minimum time it takes for all the n nodes to receive the signal. Okay, so I need to apply Dijkstra from the source. Since it is not -1, negative edges, loops are also fine. Okay, Dijkstra will work. And if to reach all the nodes, what is the time to reach 1, 2, 3 to 4? I think that is simply Dijkstra, right? So if I have a node here, so if from here it is possible to reach here everything, then okay, answer exists. If at least one node is there, which is not possible, so this path is not possible, the answer is -1. What's this question? Shall we solve it or just skip it? Okay, let's do once. Okay, let's do it fast. So given the network delay, let's write the code here only. So time edge, so we have vector of adjacency of how many nodes in nodes, double from 1 to k. Okay, adjacency, go to all the edges, go to all the edges over the time 0, time 1, time 2. We'll have adjacency of time 0 dot is back. Let's make a pair to reach at time 1 with the weight as time 2. We have the graph. It's a vector distance. That means time it took to reach at this node, right? So which will be let's say infinite, and let's have a set which will be nothing but the distance to reach here and from which node I am coming, right? So st dot insert, make a pair from 0 to 0. Are we given the source? Yeah, k is the source. Time to reach here is this. You can say time to 0 0. Now go to Dijkstra when set is not empty. Please start t dot begin and t dot first is my source node, and what is the distance? T dot second is the distance to reach here, is the time to reach here. So we can say t to reach at this node u, at this node. So let's erase it also. st dot erase p or st dot begin, and go to all the u, go to all the neighbors. If the distance to reach at neighbor, if the time to reach at neighbor d, if time to reach, why is it a 2D matrix? It is a 1D matrix, right? It is a 2D matrix. So time to reach k is 0. Everything is infinite. Okay. Still it is for if time to reach at this neighbor. So and v is neighbor dot, what's this, wait, and v, neighbor dot first, and t1 is neighbor dot second. If time to reach at v is greater than time to reach at u plus t1, this time you can say time to reach at v will be t1 plus time to reach at u, and st dot insert what, v and time of v as well and the node. But before that, so if st dot file is not st dot in, it means it exists, then st dot erase what, this pair. Okay, and after everything is over, we can go to, we have to find the minimum infinite. Go to all the nodes, right? Go to all the nodes and find the minimum distance to reach at this node. So time of I, we need to return answer is equal to infinite, then -1, otherwise answer, right? Okay, what's this? Recency of time 0 dot pushback, time 1, time 2. Okay, no memory function to call pushback on this. Why? Adjacency for every time. So time is a tuple, right? Okay, time 0 dot pushback. Time 2. It's weird why it is no matching function to call on this. Why? Let's write it again. So adjacency, we are given times, right? Vector of vector. So adjacency of time of 0 from this node pushback time of 1 and time of 2. What? We cannot convert the initializer list argument to. Okay, so times what is this? is a vector of integers, so it is nothing but a vector of integers. So vector of integers, it is 0 only, outputs back. Okay, what the hell I'm doing? Now what is infinite? It does not know. Infinite is nothing but what can be the 6000. Okay, 10 raised to 9. 1 2 3 4 5 6 7 8 9. Okay, so set std insert k comma 0 and time to reach its source is 0. To traverse from source target, we will send a signal from source set, and the minimum time it takes for all the n nodes to receive the signal. Impossible for all the n nodes to receive the signal, written -1. Minimum time to is the maximum of all the minimum time to reach is the maximum of all the maximum of all these, right? All these times, maximum of all these times. If it is already infinite, then -1. Answer should be 0. Then only. So if somewhere it is infinite only, then it will be infinite. What now? Expected is 1. Why it is? If there is something wrong, let's see. Network delay time, adjacency, create the adjacency, time to reach at every node is infinite. So set of pairs, set dot insert k, time is 0, and then so this will be 0, this will be k, right? And time of k will be 0, time to reach k is 0, and go ut. Next that is go to the neighbors v and t1. If time to reach v is greater than this time t1 plus u, then update it with this. So time to reach it v is less than, okay, is greater than, then only minimize it and st dot insert v and v. And find the maximum of all the times. So it will be second, it will be first. Is it required? T is not required anywhere, right? Of v, and then so let's see this one. Okay, after, okay, fine, but I want to solve this one. So if I erase this and then try to access it, what will happen? It should work because we have taken the value out, or what? Yeah, but if I take this here and try to find p star, now it should throw null pointer exception. Why? Because this p is already deleted, this location is already deleted. Now it will throw runtime exception. Yep. But if I take a star and then try, then erase it and then do any operation, then it is copied here and we can, okay, this will work. Nice.